Last week was Augmented Reality Expo, an annual gathering of headset makers and technology companies working in the space of virtual reality and augmented reality technologies, both for the consumer and enterprise markets. Big companies like Qualcomm, Magic Leap, to startups from all around the world showed off their new hardware. And while the impending Apple WWDC keynote, and to a lesser extent Meta's timely announcement of the Quest 3 headset, were what most people were talking about, there was plenty of new and cool hardware to show where companies are innovating in the AR space, specifically AR hardware, like the optics that are such a difficult problem to solve. I spent the day at Augmented World Expo checking out some demos, and here are a few things that caught my attention, which maybe aren't what Apple or Meta are doing right now, but are nevertheless interesting explorations in different ways to make augmented reality as common and ubiquitous as the smartphone we all have today. Let's take a look. The first device I checked out was something called Monocle from Brilliant Labs. It's a clip-on optical device, kind of looks like a cylinder, transparent cylinder, roughly 1 centimeter thick, that clips on to your glasses. And built in to this tiny piece of plastic is a tiny 640 by 400 pixel OLED display, a battery, camera, microphone, Bluetooth, and touch sensor at the top of it. It connects to your smartphone over Bluetooth to display text, so their most recent demos tap into generative AI applications. You can imagine something like ChatGPT piped directly into your peripheral vision, and the whole thing takes advantage of what we know as birdbath optics. So the tiny micro OLED panel is placed perpendicular to your viewing plane. In this instance, it's at the bottom of the unit, and through their lensing, it then is cast into your peripheral vision. It doesn't fill up your entire field of view. It's this tiny rectangle that you see overlaid through the pass-through the real world that you see here. A tiny screen where text may be usable, hopefully practical, and at the very least be readable. The unit doesn't weigh a lot and clipped onto my glasses pretty comfortably, but I did have to do a little bit of fiddling to get the alignment right so I could see the image clearly that they had on that OLED display. So right now you just have lateral movement, but I feel like the monocle could benefit from a little bit of angular adjustment as well to adjust for everyone's different eyes. But definitely an interesting device, and the whole point of it is they want to get this out to tinkerers and hackers to find the creative applications to use that they can feed through their application and then pipe into the monocle. It's $350, and they are already shipping it in these limited quantities, and definitely a neat application in the form factor that's not quite full glasses and not as invasive as contact lenses, for example. It's a monocle. Another hardware maker that takes advantage of these birdbath style optics is, of course, Nreal, which recently changed their name to Xreal. So I've previously reviewed the Nreal Lite and Air augmented reality glasses, and if you saw my review from earlier this year, I had a mixed reception to them. There's a lot I do like about the Air glasses, but one of my complaints was that the Air was limited in its tracking applications. There's a 3 degree of freedom sensor in there, but you only get that head tracking when you plug it into a smartphone and use the Nebula app, or when you plug it into something like a MacBook or MacBook Pro with the newest M chipsets and also use their application. I know Windows head tracking is coming. But as opposed to announcing a new generation of headset glasses at Augmented World Expo, what they announced was an accessory called the Beam. So this X-Beam device is a $110 accessory that acts as a pass-through between your video input source and your existing Nreal or now Xreal light glasses, plugged in via USB-C with a DisplayPort connection. So you can imagine that you plug in something like your Nintendo Switch, or you plug in or you beam something over a smartphone, but instead of using a dedicated application, the beam hardware will do image processing and then lock the image in place so you get head tracking with basically any image source. Whether it's your Steam Deck or your Switch. This is something I've wanted with the Nreal Light glasses since I first used them. The Beam has a built-in battery, but it also has two USB-C input ports, so you can charge this while also connecting it to a device, although you probably need another splitter to power that device if you're running something like a Steam Deck or your Nintendo Switch. I don't know if it can charge that device as well as powering your Xreal Light glasses. It's available for pre-order now, but I'll wait till we get our hands on a test unit before giving a further assessment and going further in depth with the Beam, as well as an interview I did with Xreal's co-founder, so stay tuned for that video. One of the things that we hear augmented reality is supposed to be great for, one of the dream potential applications is productivity. We've heard over at Meta, Michael Abrash talking about his dream of infinite desktops. And you get a limited version of that with Meta's headsets, with a web browser and social media applications, but nothing that's going to replace your laptop, at least nothing yet. Well, that's the hope of a new company called Sightful, which at Augmented World Expo was demoing their new laptop device. They call it the first AR laptop device, Spacetop. And the idea behind this is you have the guts of a high-end smartphone, so in this case a Qualcomm Snapdragon 865 processor running their custom Spacetop operating system, but instead of your standard keyboard, battery, processing unit form factor with a display, there is no panel, there is no LCD panel on that keyboard. Instead, there's a hardwired Nreal Light glasses. They've partnered with Xreal to use the Light glasses so that you're wearing these track glasses and seeing that operating system in headset only. I got to try out the Spacetop laptop, and for the most part, it worked. It reminded me a lot of using Nreal's Light glasses and their smartphone applications, but here, instead of using the Nreal app, you're using the Spacetop OS, which mimics the traditional desktop with windowed browsers and a few web-based productivity applications. The keyboard unit itself has a touchpad on the bottom, and there are gestures built in to calibrate your virtual desktop. But the device seemed a little bit limited by the AR headset hardware. It's limited by that 52-degree field of view that you have in the Light glasses. And so you're not really seeing an infinite desktop. What you're seeing is a letterbox window into this virtual desktop, which you still have to move your head around to reveal the other portions, or you can collapse it and kind of scale the desktop to just be fitting into that 52-degree field of view. Using the 1080p per eye displays on those Nreal Light glasses, text is fairly readable. It's kind of the same experience I'd had before on the Nreal Light and the Nreal Air glasses in terms of how usable and readable it is. So it's not as sharp or clear as having a high-res monitor built into your laptop. But you get the benefits of, privacy and scalability so that you can put up as many windows as possible, once again, though limited by the field of view of the headset. The unit also, interestingly, has the headset tethered, hardwired, soldered right in to the cable onto its motherboard. So you can't disconnect it to pack it up and store it away. They have this interesting laptop cover that folds in place and covers the folded headset if you slot it into position on top of the keyboard, but that kind of makes it a pretty thick and unwieldy form factor. If anything, I think the bulkiness of this design works against what they're going for. What I'd like to see is, if they're going to design something like an AR laptop, so to speak, is the glasses to be able to be modular, to be separate. You can separate it from the laptop and processing unit so that that can be collapsed flat and put into a very thin sleeve or your backpack. Here, it has more volume, I think, than makes sense for what they're going for. But again, I'll have to see how practical it is when we eventually, hopefully, get a test unit to review. Moving away from headset hardware and optics is input. And one company whose demo I tried I found interesting is called Double Point. They're a Finnish startup working on software to turn off-the-shelf smartwatches into hand-controlled input devices for VR and AR. The idea is, instead of using a hand track controller like what you get with the Quest 2 or Quest Pro, or EMG neural wristbands like the ones that Meta's working on, they can train AI models to infer your hand position and hand gestures using the basic and simple accelerometers and IMUs that you get on something like a Samsung Android smartwatch. And that's exactly what they had at their booth. So they put a Samsung smartwatch on my right wrist, and they've trained their model knowing which wrist that you calibrate it for, so that I could, in their demo, use ray casting and gestures like tapping my fingers to click, and the system would recognize that even though I was just wearing a standard off-the-shelf smartwatch. And it worked with various degrees of success. There are actually different levels of sensitivity that they've tuned as presets. And even with the most sensitive one, I did get some failed detection, so it wouldn't be able to detect some of my clicks. And I was trying to test for false positives, and again, got various degrees of success. One of the issues they have is that the smartwatch, they're limited by that hardware. It's connected with Bluetooth to the Quest Pro application that they were using, and in the convention environment, there was a lot of signal noise, and so there was a lot of latency in getting that response. But what the demo showed me, when it did work, it was pretty impressive, and it gave me some confidence into using AI-trained models to improve input tracking, which is what the Quest 3, which was just announced last week, is supposed to do with its new controllers. Doesn't have that large tracking ring that you had in previous VR headsets from Oculus and Meta. Instead, they're using fewer tracking lights, but also combining it with AI models to improve the tracking over time. So whether it's maybe better tracking for physical controllers, or a way to add more input using simpler devices, maybe even like legs in avatars in VR and AR, this gives me some confidence that these AI models could improve upon the inverse kinematic IK models that we've seen so far. I've mentioned a lot of these headsets that we've seen using bird bath optics. It's a very cost-effective way to introduce augmented reality, and X-Real has done a good job of incorporating that into sunglasses form factor. And so I was really happy to see some innovations in bird bath style optics from a company called Ant Reality. They were formerly known as Ant VR, and they had launched a failed crowdfunding campaign to make their own headset. So they've pivoted now to just developing optics modules that they can license out to companies like X-Real and other headset makers. And at Augmented World Expo, like they had at CES this year, they were showing off some new optics modules that make use of what they called mixed waveguide optics. Even though there's a lot of bird bath fundamentals, I think, still here, starting with the use of micro OLEDs as display panels, as the image source. Here, their special sauce is the way they're channeling that display source through a traditional beam splitter and combiner path, but that path is in a single plastic panel, which is the waveguide. And what's neat is that they've designed these modules with different field of view attributes depending on the thickness. So they're giving these trade-offs as options to headset makers. A 9mm thick module would have an 85-degree field of view for that augmented reality image, but a headset maker could opt for a different unit that has a thinner 6mm module with a narrower 56-degree field of view. Ant Reality also showed off what they called a crossfire module, which offered a 120-degree field of view at a 13mm thickness. And what was super interesting here was that each optics unit was actually taking advantage of 2 display sources. So as opposed to a traditional birdbath optic system where you'd have the OLED panel on the top or the bottom, kind of like the monocle has it on the bottom, or the X-Real Airs has the display at the top, the Crossfire unit here had 2 displays, one on each side, left and right, of their optics module, and they would then combine them through this waveguide to create an effective 3K resolution image. 2 2K sources on each side combined to create a 3K image that would have all the benefits of your micro OLED-based birdbath style optics, so you don't have distortions, chromatic aberrations, very clear in what I saw, but also a very wide field of view, 120-degree field of view. Combine that with polarizing elements, active polarizers, or even mechanical shutter that they have, and they can even turn that from an AR device into a VR device by just making the displays completely opaque and then still having a relatively wide field of view. 120 degrees, certainly practical for VR, even at that 13 millimeters thickness. Which is pretty thick, yes, but then that's going to be on headset makers to figure out how to make units that are, again, socially acceptable, comfortable to wear, and have good heat dissipation and can run for a good amount of time using this type of optics. But the benefit of this is that the components are all relatively affordable. So as opposed to making, Magic Leap or HoloLens style waveguide with truly expensive optical elements, they can do it here at a tens of dollars per unit, which then makes the headsets more affordable in the consumer range. So that gave me hope that companies like X-Real could iterate on their devices and still keep something in that's usable and practical on a daily basis in the couple $100 range price point. So this is going to be a massive week for VR and AR. I mean, Apple is 99% going to announce their headset that they've been working on for so long this morning. We believe it so much that as you're watching this, I am driving down to Cupertino to attend the keynote. We were invited for the first time to attend one of their announcements. And so if and when they do announce a headset, you can actually tune back onto this channel tomorrow for my full report. But feel free to post in the comments below your expectations, your hopes, your reactions to the announcement that comes later today. And I'll be there watching in person and giving you the full report tomorrow. Thank you so much for watching. It's truly an exciting time for those of us covering VR and AR for the past 10 years. Everything could change tomorrow, later today, with that announcement. So I will see you on the other side of it. Bye.